Hello and welcome to Solving Systems of Linear Equations. This is section 3.1 and 3.2 in your textbook. Alright, the first method we're going to talk about is graphing. If you are given a system of two linear equations, basically two different lines, you could have no solutions, and that's what it looks like when your lines are parallel. So we call this inconsistent. So that's something you need to know. Inconsistent. Or you could have at least one solution, and we call that consistent. So that is something you need to know. I didn't mean to cross it out, sorry. Now, if it has at least one solution, your options are it could either have exactly one solution, and that's when your two lines cross exactly one time. We call that independent. Or it could have infinite solutions, and that's when your lines are the same line, they coincide, and we call that dependent. So when you're asked to classify, your choices will be either inconsistent, or consistent and independent, or consistent and dependent. Alright, let's look at a few examples here. I've got the system 4x minus 2y equals negative 1, and I have 2x minus y equals 7. So I might ask you a question like, is 3 6.5 a solution? And if it is, when you plug it in, it will be true. But you have to plug it into both equations, and it has to be true in both equations. So if I did 4 times 3 minus 2 times 6.5 equals negative 1, then I have 12 minus 13 equals negative 1. That's true. So maybe it is. But you can't say yes yet. You have to plug it into the other one. 2 times 3 minus 6.5 equals 7. So does 6 minus 6.5 equal 7? No. So the final answer is no. That point falls on the first line, but not on the second line. It's not the intersection of the two lines. So no, it is not. I might also ask you something like, how many solutions does this system have? So I don't necessarily want you to find what the solutions are. I just want you to tell me how many there are. And so based on what we just said, if there could either be none, and that would be parallel lines, or it could be 1, and that would be two lines that cross, or it could be infinite, and that would be the same line. So what we need to do to check for that is to just check the slopes of each one. If they have the same slope, then they're either going to be the same line or parallel lines. So if they have the same slope, then we know it's either no solution or infinite solutions. If they have different slopes, then we know automatically it's one solution. So let's check that. I'm going to rearrange the first equation. Let's see, so we've got negative 2y equals negative 4x minus 1. Y equals 2x plus 1/2. So the slope is 2. And then we take the other one. Negative y equals, I'm subtracting 2x from the other side. Oops, plus 7. Y equals 2x minus 7. Okay, they have the same slope. It's either going to be none or it's going to be infinite. Well, we just saw that 3 and 6.5 was not a solution, so we know automatically that it's not infinite, but the way that you would check that is you'd say, okay, are they the same line? If it's infinite, they're the same line. Well, they're not, because they have different y-intercepts. So we know that these are parallel because they have the same slope. So they have no solutions. And if I asked you to classify this, you would tell me that it is inconsistent. So this time we're going to solve by using a graph. We are actually going to graph these two lines and find out where they cross. So in order to graph these, you could either use the intercept method or the slope-intercept method. I'm going to show you the intercept method just because we haven't done that in a while. My x-intercept for the first one, if I plugged in a 0 for x, I know y would be 4, just by 0 plus y equals 4. So I'm going to plot a point at 0, 4. If I had 0 for y, then I would have 2x equals 4, and so I would have x equals 2, 2, 0. Here's my other point. Connect the dots. Make sure you do it straight because we're trying to actually find the intersection of these two lines. Alright, the other line, x plus y equals 3. If x is 0, y is 3. If y is 0, x is 3. So 0, 3, and 3, 0. Well, other way around, 0, 3, and 3, 0. Connect the dots. And I'm doing this freehand, which I don't recommend you do when you're actually trying to solve a system using graphing. Use a ruler. I can't use a ruler on my iPad. But we can see that these guys cross right here. So the ordered pair there is 1, 2. 1, 2 is the solution to this system of equations. Now, you could do this in your graphing calculator also. And so the steps that you would take is you would go to y. Hold on, I'm going to switch the page. Alright, you're going to enter your equations into y1 and y2. You hit the y equals button up in the top left-hand corner of your calculator, put these equations in. You have to do it after you've solved for y. And then you're going to hit graph, and then you're going to press zoom 6 because that'll give you a standard window, a standard 10 by 10 window. This may or may not work for your system of equations. For the one we just did, that did intersect within a 10 by 10 window. If your intersection is outside of the window, you look and see where it's going to be, and you adjust the window so that you can see it. And there's a button up there called Window. And you change your x and y max and min, and that will help you find the intersection. But once you want to figure out the exact intersection, you're going to hit second and then calc. Calc is right above the trace button up at the top, second calc, and then you're going to choose the intersect option. It's going to say first line, you hit enter. It's going to say second line. It will toggle you automatically to your second line, so you hit enter. And then it says yes, and so you scroll over approximately to where the intersection is and you hit enter. And the reason for this is because if you had a whole bunch of lines graphed in there, then you would be telling it which ones you want to find the intersection of. And then once you've hit enter, it will pop out the solution for you at the bottom of the calculator. So that's really easy to do when you have your graphing calculator. And so for our example that we just did, our solution we already said was 1, 2. And that's one solution, so we would call that consistent and independent. Our next method of solving is substitution. I know you guys have done this before. The best way for me to demonstrate or for me to explain it is to demonstrate it. So let's just do an example. I have these two equations, 2x plus y equals 9, 3x minus 4y equals 8. In order to do substitution, we have to solve one of these two equations for one of its variables. We need to isolate a variable. And in this case, I'm going to pick this y because it's the easiest one to isolate. You can isolate whatever you want. Go with what's easiest. So if I rework that, I'm going to have y equals and then negative 2x plus 9 because I subtract 2x to the other side. Alright, then you take that and you substitute it in. You take this y and substitute it in here for this y. So now I have 3x minus 4 times, and then that y was negative 2x plus 9 equals 8. And I am going to distribute 3x plus 8x minus 36 equals 8. 11x equals 44. X equals 4. But you're not done when you solve for x. You have to solve for y too. So now go up here where we isolated y, plug in the 4. Negative 2 times 4 plus 9 is negative 8 plus 9, which is 1. Y equals 1. And the answer, the solution to your system of equations is going to be written as an ordered pair 4, 1. And if you're asked to classify, because we have one solution, this is consistent, and independent. Sorry about that. That's ugly, but you can read it, right? Independent. Here's another example I want to do with substitution. So same rules apply. I'm going to isolate this y right here. I'm going to make this y equals 3x plus 7, and I'm going to plug it in to the first equation. You have to remember, because it's a mistake I've seen before, is people will isolate y and then plug it right back in where they got it. But when you plug it back into itself, you're just finding the same line and you didn't do anything with the first line, and it's not going to work that way. So you have to plug it into the other equation. So we've got 6x minus 2 times 3x plus 7 equals 5. So we've got 6x minus 6x plus 7, minus 14, gotta remember to distribute to both, equals 5. 6x minus 6x is no x's, so we have negative 14 equals 5. That's not true. That's never true. No matter what x is, that will not ever be true. So when you come across something that's never true, that means you can't solve for x. It's not going to work. There is no solution. When you come up with something that is never true, you know your answer is no solution. And if you're asked to classify that, that is inconsistent. I'm getting real professional with my writing here today. Alright, and the third method that we're going to use today is called elimination. This is also known as linear combination, but elimination is what we use most often. Alright, so the point of elimination is you're going to determine which variable you want to eliminate. It can be x or y, it doesn't matter. Go with whichever one's the easiest. In this case, I've got a negative 2x and I have a 1x. It'd be easier for me to eliminate the x. And the way I'm going to do that is I'm going to multiply this entire second equation by positive 2. And the reason I did that is so that when I do that, I get 2x minus 6y equals negative 6, because you have to do it to every single piece of the equation. And I'm going to combine it with the top one, which was negative 2x plus 7y equals 10. You're just going to take these two and add them up. So that's why I chose a positive 2, because it's the exact opposite of negative 2. When I add these up, I get no x's. I get positive 1y equals, and negative 6 plus 10 is 4. So right there, I now know y equals 4. Now to find x, you can just take that y and plug it back into either one of the equations you started with. It doesn't matter. So I would say x minus 3 times 4 equals negative 3. I'm just going with this one. So x minus 12 equals negative 3. Add 12 to negative 3, x equals 9. The solution is 9, 4. Again, consistent and independent. Alright, I want to do one more elimination example. I have 4x minus 3y equals 10 and 8x minus 6y equals 20. So let's eliminate x by multiplying this first equation by negative 2. That way we have negative 8x and positive 8x, which eliminates. So I have negative 8x plus 6y equals negative 20. And then if I copy down the second one, 8x minus 6y equals 20, and add them together, I get 0 plus 0 equals 0. And that's always true. That's always true no matter what x is and no matter what y is. So when you come out with something that is always true, no matter what, then those are the same line. And you can kind of tell that because if I just, change the sign on here, they're the exact same line. So this is infinite solutions, and remember we classify that as consistent, dependent. Something else I just want to point out, this is your classification, this is your solution. So if I asked you to solve this, you wouldn't tell me the solution is consistent dependent. That's the classification. The solution is infinitely many solutions, or infinite solutions. Not infinity. Infinity is not the solution. It's every number, every ordered pair that exists on this line. So it's not everything that exists. It's everything on those two lines. They cross each other everywhere that they both exist. So remember, if it's always true, it's infinitely many solutions, and if it's something that's never true, just like when we did substitution, it would be no solution. All right, so that's it. You guys have a great night, and I'll see you tomorrow.